I'm CK. Tonight we're going to be doing a clock. I needed a new clock source for my studio rack, so looked around on Thonk and saw this. It's a Shakmat Haun from Shakmat out of Belgium. I have not, it's one of the few countries in the EU I have not been to. I have not made anything from Shakmat before, so this will be interesting. Hope you enjoy the video. As you can see, it's got something on the outside. It's a MIDI connector, I believe. Yeah, it is. So I believe this can also send whatever clock it's generating to a MIDI input, which is really nice. So let me get my X-Acto knife to open this box. Very serious box with fiberglass reinforced tape holding it together. Okay, ooh, nice little piece of paper to start off with. The diagram, it tells you how to do it. It's got its MIDI combination, MIDI. Nice sticker to go on my sticker wall. A subset of the logo. And here we go. Oh, it's got one screw that's got a little... Oh, that's a stud. That's not a screw. That's mounted on the panel. Huh, interesting. So let's look at the front panel to give us some interesting idea of what's going on with this thing. I'll zoom in a little bit. Not that much. About like that. Let's see what we've got. Looks like these are jacks. There's clock in, there's an external. I'm not exactly sure what that means. Clock 1, reset, clock 2. I'm assuming, well, I don't know if those are inputs or outset. I would think they'd be outputs, except that the reset wouldn't be, but I could be wrong. Here's a nice dial for BPM from 60 to 240. And another external signal, clock 2, and then swing to give you a little variation in the BPM, which is nice. And it sets here, I guess. No swing. This LED is indicating no swing, no stop, both. And then there's a play, pause, something. And tap tempo button, I guess that's reset again. RST, I'm assuming that's what they mean. And I guess that's going to be another MIDI connector. Don't know for sure. That's just my guess based on the front panel. And of course, a bunch of little LEDs scattered around. What we got here? Block of styrofoam, which I'm not in love with. I'm not a big fan of styrofoam or bubble wrap, but take what we can get. Another MIDI cable, so it looks like they gave us two TRS to MIDI outs. I don't think they meant to do that, so I think that this one here is a mistake. And we've got eurorack cable as usual. One knob, that'll be the BPM knob. Put that in the mechanical bin. Here's pack 2 of 3. Apparently they organize things in packs for assembly, and they've got a build guide online, and there's the two, there's the IC socket and the IC that makes this thing go. And now we'll get the box ready for recycling. And I'm going to open these up. I would not recommend you do this. I would recommend you go in the order that open them only when they're needed when you're assembling. I'm doing this for demonstration purposes. I'm going to back the camera back off. I didn't realize I had forgotten that. See what we got in here. We've got one switch that feels loose enough to be a tap tempo type switch. There's another switch like that. A couple of resistors, a pot, another tap switch, some caps for that, different size caps. Is this a voltage regulator? Power connector, pin header, little bitty LEDs, and a couple of jumpers. Wonder what the jumpers are going to be for. So that's the contents of bag 1. And I guess we're not going to be doing it in order because the circuit board is in bag 3. So you kind of need the circuit board before you do anything else. So let's pull that out right now. Again, if I did unboxing for a living, I wouldn't do unboxing for a living. I'm so bad at opening things. Oh, look at that. Okay. That's too bad. For me, not for everybody else. There's one little board, and here's the main board. It's got 2 surface mount parts already surface mounted on, which I would have liked to do that, but that's okay. And then we've got a couple of resistors, some capacitors, a couple more resistors for the LEDs and so on. And I think that's a diode, but I'm not certain. So that's the board. So swing is a pot. So it's going to go, swing will go there, BPM there, swing there, and then the jacks. And then I guess okay, so it looks like these 2 boards connect with pin headers right there, and then this is driven, this is held by that stud because I expect whatever connector goes there, they wanted to be able to support it with a good sturdy stud. Okay, that's those bits. Let's see what's in the last bag. Just a bunch of more mechanical parts, jacks, and I'm going to put these in a different bin. I wonder why this one's lime green. I don't know. So as you can see, there's not a lot of parts to the kit. Always be careful when you have bags like this that there may be something still left in there, and there is. There's an LED hiding in there. So I'll forgive them the block of styrofoam because at least they didn't use plastic bags for this. I can recycle these bags. Okay, so I'll get the soldering iron heated up, take a look at their build guide, which they say is online at their website, and it doesn't look like it's going to be too complicated or too long a build. Of course, the first thing that the build guide says, or one of the first things that the build guide says, is don't open all the bags and mix the parts up like I did. Their primary concern is, since the LEDs are all clear, and some of them are green and some of them are amber, if you do as I did and just dump them out like that all together, you might never get the right ones in the right one. But I'll just show you a little technique for that. So my meter is set to continuity, so when you touch the leads or touch two conductive surfaces, it'll beep to show you there's power. I mean, there's a connection between them. Well, that also means that the meter is sending a small bit of current through so it can hear itself. And that small bit of current allows you to, let me flip this guy over, put your negative lead on the negative side of the LED and positive lead on the positive side, and the LED lights up. See that? So we can see that that one's an amber one. And this one over here, yep, they're touching. Let me spread this out just a hair for demonstration purposes only. Put that one on there, and that's a green one. So if you've ever get these clear ones and you don't know what color they are, just use your meter. Even if you do mix the parts together, the only one that matters in this case are the LEDs, and you can find out what colors they are very quickly. So this, by the way, this is a mono jack. The lime green one is a stereo jack. I did not expect that, so took me by surprise. So we're going to go in order, in build order by what they recommend. Always a good thing. First time building a kit from a particular manufacturer, I always go through the build guide the way that they recommend, because you want to, you learn different designers' styles. So we'll put this in. Voltage regulator. It's interesting, the pins are broader. They used the software that just laid out this board used a very small version of this. It's not bad, just interesting. So this is, the board is, as you can see probably, it's marked as Clock Upon version 1.0. And as we put this all as we start soldering, we can see the board is pretty good. The solder pads are very small in circumference, in diameter, but they are through-hole plated, which is always a plus. Now we're going to do the 4 mono jacks first. And interesting that this build guide author does not obsess about, whoop, that's the wrong one, that's the wrong one there. I did the wrong one already. Does not obsess about making sure that you get the panel on board before you solder anything. I will, just because I find that to be a good idea. And the stereo jack goes up here. So again, I'm going to put the front panel on it to make sure everything is aligned. I'm going to tack one. I'm going to put one panel nut on one of the jacks. Get my locking pliers to hold it flat. Do a pin. Make sure everything's flat. Now I'm pressing down a little bit with my finger, this finger, to put a little tension on the board. Not too much, I don't want to bend anything, but I want to make sure that the jacks are all flat. Now we're set, and I'm going to go ahead and solder the rest of the pins. Now we'll do the small pot, and the small pot is the swing pot, and the pin is a little teeny bit bent from shipping. Please always use a lot of solder on these support lugs, because they're what's taking all the pressure or the torque of turning these as you use it throughout the years. Now this is the big pot, and it has an alignment knot pin here that we're going to want to cut off, and you can cut that off with your standard wire cutters, even though I don't use my standard diagonal cutters for this. I have a pair of carbide steel jawed pliers which will cut through anything, and they are much stronger and they will not deform or get any damage to the jaws when you're cutting something like that little tab off. Let me check the pins on this. Pins on this all look good. This is our BPM control. Now we'll do the IC socket. Make sure the notch is going in the right direction. And we'll mount the socket the way I mount components like this, like pin headers and so on. I just tack one leg down, and you notice I didn't pay any attention to whether the socket was flat or not, or aligned, because I don't care, because I'll hold it with my thumb in the back, heat that solder joint up again, press firmly, and that makes sure it's flat on the board and all aligned correctly. No muss, no fuss. Now one thing I will say is this, be very careful right here. This socket pin is right next to the surface mount capacitor, and if you're actually with both these two, be very careful not to put your iron on this component. Not because you're going to damage the component necessarily, but you could inadvertently desolder it or heat it up enough so it moves off its solder pad. There's that socket. Now we'll do the small headers. So the small headers, which go here, are for the TRS MIDI. It can be interpreted two ways. So there are jumpers. The jumpers that came in the packaging allow you to select how your MIDI signal is being interpreted. And now we'll do the big power header. And again, it looks like a diode and a resistor, very close, surface mount diode and resistor, very close to where you're soldering these pin headers. So be careful. Okay, that's the power connector. Now we're going to do the pin header. This board gets the short pins. Now we're going to put some resistors on the bottom board, and unfortunately for me, the designer of this kit likes stand-up resistors. I don't like stand-up resistors. I find them to be a source of potential problems, and I'll show you why in just a second when I put them in. So, it's standing up, and the problem is during assembly, later handling and so on, it can be nudged or shoved to the side. And in this case, we're not going to have a problem because the component next to it is a switch with a plastic body. But I've seen other layouts where if the resistor bent over, it would, this long lead that's exposed would ground itself or short itself against another component or a chassis. So I have a philosophical disagreement with doing resistors in a stand-up fashion. Flat on the board means you're never going to bend it over. And I just find that to be safer. Geez, I'm going to get this done in a lot less time than I thought. I will admit, the size of the cardboard box this came in made me think that this kit was going to be a lot more extensive than it was. There's our resistors. Oh, it's funny, he even says, be careful you don't have too big of a loop here in that wire because you might ground against the aluminum panel. Well, if you would lay them flat on the board, you wouldn't have that issue at all. Now put the push buttons, again, I'm just staring a little bit for a second because we've got push buttons times 3. Buttons are easy to place and solder. Before soldering, blah blah blah. Before soldering, we recommend to place the 4 buttons, then flip the PCB. Don't confuse us. There's only 3 buttons. And they don't seem to be polarized, which they shouldn't be. It's just interesting that there are 2 little dots by one, well actually no, there's 1 dot, 2 dot, 3 dot. Okay, that's just to indicate which switch is which. It has nothing to do with the switch itself. So next step will be to assemble the board like so. I'm going to use the front panel to guide me on this. So we'll go through that hole in the back PCB. Actually, I'm confusing myself. I'm going to put this board through, make sure that's all the way through, including, that this potentiometer is taller than anything else on the board, so it's setting the height. That's a typical thing for eurorack. There will be one component that is taller, or one set, it may be the jacks, that's taller than the rest, and it sets the tone, for lack of a better term, about how high things should be. I'm going to put this panel nut on to give me some stability. Then put this through, make sure I'm through the pin headers and the shaft, the threaded shaft, and that holds it like a little jig, and I can make sure it's not tilted. And I'll get my little roller out and make sure I'm okay. Now I can solder those pins. You may choose to do this a different way. You may choose to do it the way he's described in the guide. I'm just doing this way because I know it's going to work. Because in the end, I'm going to get my little locking tweezers. This is up a little bit, so I'm going to squish it down just a little bit there so I can get that pin flush with the connector. Again, you're soldering real close to this IC socket, and your soldering iron is hot, and that's plastic, so be careful you don't melt it. So now we've got the two boards mated, and I'm gonna take it apart again because we're gonna do the LEDs. But actually, I'm not gonna do the LEDs. I didn't know I'd be putting this together so quickly. So I'm almost done, but I don't want to be almost done because I'm not ready to test this evening. So I'm going to stop for the evening and go feed the cats because I'm sure they're kind of upset that I'm not in there feeding them yet. Okay, so the next step is to do the LEDs. And the green LEDs go And the green LEDs go 1, 2, 3, and the ambers go 1, 2. Okay, and we're going to put the PCB back on so we can make sure the LEDs go all snug. If I could get this panel nut started, that would be helpful. He wants them flush with the front panel, not protruding. I kind of like them protruding, so I'm going to have them protruding a little bit. That's personal preference. Doesn't matter to the functioning of the unit. The reason why I like them protruding a little bit, I actually have a sensible reason, is occasionally I'm working at an extreme angle, particularly if I'm at my keyboard and I have to turn to the side or reach quite a bit away to get to the rack that has my eurorack gear in it. So I like to have a little more, I like to have the LEDs out a little bit so I can see them from an angle. PCB in, I mean the brains of the operation in, the IC. Get all the tape off it. Bend all the legs in a little bit against the side of my workbench. notch to notch. All in, all flush. Now, put all the panel nuts on, and I'll do this in fast motion. Now we put the pot knob on, and fortunately this is a flat spot one. Fortunately, because I'm such a spaz at getting these aligned right, that having flat spot guides helps me a lot to not mess up. And that goes smoothly around. Let me check all the jacks to make sure nothing funky went on. Nope, they're all good. And now we'll put the power header on, the power cable on, and -12 is down here. That's the red stripe side. Okay, so I think we're done. Oh, we've got to put the jumper caps. These jumpers set up how the TRS MIDI connection is set up, and quite frankly I don't know right now, so I'll have to look in the user's manual. I'm gonna leave them off for right now because I don't think they shouldn't need to be on. Actually, why don't I'm gonna put them on both horizontal. That may not be what I end up using them as, but at least the jumpers will be in place and I won't lose them or misplace them. We've got 2 panel nuts, but I don't care about those because I'm going to be using Befacco knurlies as I always do. Okay. And that's the end of the build. So here's what it looks like. Here's the front, side with stand-up resistors, ARG, back, jumpers and support nut for this daughter board, other side, top, and bottom. And let's go put it in the rack. Okay, we haven't turned it on yet, so let's do that. See if we get any magic smoke. Nope. Seems to have turned on just fine. If I plug the power cable in, which I did not, because I'm an idiot. Let me plug that in. Okay, so now it's plugged in. So what we're going to be doing to give this a try tonight is we're powered by a frequency central Routemaster, and the clock signal will go to the clock in on the Division 6 sequencer, which is going to send the signal to the System 8 frequency central System 8 envelope and the frequency central more VCA, and both coming from the ADAC systems VCO. Okay, as you can see, in the idle state, it's ticking along, putting out clock from clock 2. That clock 2 is showing on the oscilloscope. Clock 1 is going to the sequencer. So let's turn the sequencer on, and it's responding to external clock. Oh, I got to turn the amp up a little bit. Now we'll use the BPM knob. Sounds like you'd expect. I'm going to try and do a tap tempo, and I believe, let me look at the manual again. Clock 2 X'd and tap 4 notes on the play button, 4 quarter notes on the play button. So that's this, and we'll go 1 and 2 and 3 and 4. Let's see what that comes out to. So that's the tap tempo that I did, and as you'll notice, the BPM knob is still set way high, so it's overriding that. Let's see what happens when we turn the BPM knob. When we turn the BPM knob, it jumps right to that BPM. So if you have tap to tempo and you want to change and you don't want to have that abruptness, if you want to ramp or bring it up differently, just be aware of that. It will jump immediately to where your BPM potentiometer is set. Now I'm going to make one switch. We're not going to hear this. I'm going to take the, let me take the amp down. I'm going to take clock 1 out of there. Actually, why don't I do it this way first? We'll do audio first. This will be some swing. So I'm going to start turning the swing knob clockwise. Fully counterclockwise. Fully clockwise. Halfway. So that's interesting. I'm going to go ahead and pull the amp down, take this out of there, put clock 1 on the oscilloscope, and now you can see, let me see if I can, you can see the way the traces are when it's fully counterclockwise. Let's go fully clockwise. See the way you can see 2 peaks getting closer to each other. So it's bump para, bump para, bump para. And when I go fully clockwise, fully clockwise, that extra beat just goes away and it's just a triplet. So that's interesting. I'll take it all the way back out. Now it's back to 4 even beats. So that can certainly be fun. So that's the clock of Haun. It, as you saw, is a pretty simple build. Shouldn't take you very long if you're an experienced builder. I'd say half hour, 45 minutes, quite frankly. If you have never built a eurorack module or electronics, this would be a great one to start with. It's not very difficult. There aren't a lot of parts, and in the end you have a good solid clock signal, which every eurorack toolbox needs. So all in all, a good kit. Thanks for watching the video.